Hey y'all, happy last lesson for Unit 2 of Mod C. Obviously it's lesson 3. So today during instructional time, you will learn the difference in patterns of interactions that exist between organisms and an ecosystem. During work time today, you're not really going to have any work. You're going to be playing a game. Yes, there is a worksheet to go along with it, but that is it. Okay, cool. Also, just a heads up, if this doesn't get cleared in the system, I might add something else into it, but there'll be another video attached to it if we cannot use the game. Okay, just a heads up. So we'll find out because I haven't got an email back, and I was told just to go ahead with it, and we'll see what happens. Okay, cool. You good? You good? You a hot mess.
What?
You a hot mess. Anyways, lesson 3. That was Kyler, he was joking. So yeah, today during your lesson objective is you will learn and understand how different animals interact with each other in an ecosystem. You can follow along in HMH if you want to. You don't have to. If you want to, your username is your school email, which is your school ID, that 5-digit number, at rcs.k12.il.us, followed by your password, which will be capital R Tool 1. Okay? Following along now. We don't need this new tab. We'll be done with lesson 3 in a bit, hopefully soon. There is 3 explorations for this, but I'm gonna cut one of them really short, the last one. And I'm hoping to cover the other ones very quick too, to give you more time to play this game. Jinx, you wanna say hi? No? Okay, cool. She crazy Kiki. You ready to be a big sister? Ready to be a big baby sister? Yeah, big baby sister. Alright. You're going to do on this one. It's most likely going to bring you to Unit 1, but you should know how to by now if you want to follow along. Like I said, but you don't have to. You're going to go to Contents, hit the Unit 1, hit Unit 2, Lesson 3. Is she going to attack something? I don't even know. Yeah, we're not going to do lesson opening. Yeah, let's skip it. Okay, so starting with Exploration 1. Analyzing feeding relationships. Think about all the different ways you are connected to other organisms. Both plants and animals provide you with resources that you need. You may eat meat from a variety of animals. You get good food and fiber from plants. You also provide resources to some animals, such as blood a mosquito gets when it bites you. Sorry. Another way you are connected to other animals is through social interaction. For example, you'll laugh with your friends or play fetch with your dog. Or if you're Jinx, you'll be crazy and jump all over people. Right, baby Kiki? Yeah, she's just staring at me. Feeding interactions and relationships are some of the most important connections between organisms. Without the energy and nutrients provided by food, organisms would starve. Plants make their own food, but animals must eat other organisms to get the energy and nutrients they need. Some animals eat plants, some eat animals, some eat both. The ones that eat plants are called herbivores, the ones that eat animals are carnivores, and the ones that eat both are omnivores. You should know something by now. Please stop. Sorry, Jinx was being crazy and biting lights. And yeah, no. So explore the image below to see more animals feeding relationships. So koalas' diets consist of eucalyptus leaves. There we go. Koalas are one of 3 organisms that feed on eucalyptus leaves, which are low in nutrients and contain many toxins. Koalas are herbivores. Lions feed only on meaty animals of the savannah, such as zebra or gazelles. They catch prey from the large herds that graze near them in their watering holes. Lions are carnivores, and then there's flamingos. The feathers come from red pigments in their food that include red algae, and shrimp. They eat aquatic plants, insects, and small fish as well. So these are omnivores. Discuss out of those 3 animals, the lion, koala, and flamingos, which animal has the most diverse diet? Okay, a puzzle, which animal has the most diverse of those 3? which one has the least diverse. So which one has more options to eat while the other one has less options to eat. Honestly, this will just be one Ed puzzle question together, okay? There we go. We're not going to discuss those ones. Predator versus prey. Okay. A predator is an animal that captures and eats other animals. The platypus is a carnivore, Perry the platypus, an organism that feeds exclusively on animal flesh. I did not know that. Perry the platypus. Anyway, its prey or the hunted food includes shellfish, worms, and insects, and fish larvae. Most carnivores have sharp teeth to hold or rip their prey. Stop. Rip their prey, but platypuses use a gravel scooped up with their water-dwelling prey to grind food. If anyone wants a free cat, I'm gonna give Jinx away. I'm kidding, but no. Watching you. Grind food into small pieces. As with other carnivores, the number of platypuses in the area depends on the availability of prey. Factors that limit prey will also, in turn, limit platypus. Platypi. If you don't know what a platypus is, here's a platypus. Also, both of these are predators. Spider. Obviously, spider is prey as well too, and most likely platypuses too. Herbivores eat plants or algae. Unlike carnivores, the predator or prey, the herbivores eat plants. Like I said, herbivores eat plants. Some herbivores only feed on leaves of particular plants, like koala, while others have a wide variety of plants, like they can eat flowers and stuff. The mountain gorilla, for example, feeds on the leaves and shoots of trees. The monarch butterfly feeds on the milkweed leaves as a caterpillar, and the nectar from flowers as a winged adult. Algae are unicellular or multicellular organisms that can make their own food through photosynthesis. Algae lives in water ecosystems where they collect light energy from sunlight. They provide food for a large number of herbivores. Kelp is a type of algae that can grow to be more than 50 meters, I think, in length. Crabs and many other shellfish eat kelp. These animals are food for carnivores such as a red octopus. Oh, look at the little manatees. They're so precious. Manatees are herbivores. These manatees are feeding on lettuce and other plants in a natural spring in Homosassa, Florida. Don't know where that is. Okay, there's one other thing in the exploration one I need to cover. My coffee is really hitting me. Don't drink coffee late at night. It's not late at night, but you know what I mean. Ever listen to Miss Peterson and try a bang? I tried one of the coffee bangs, and oh my god, I mixed it with a protein shake, but still, tastes like Kellogg's, which I mean is okay. Captain Crunch, there we go. That's what I meant by Kellogg's. Anyways, relationships between population sizes. When mice begin to invade grain storehouses, farmers may bring a few cats to their farm. So like Jinx, we had a couple mice a couple weeks ago, and since it's getting cold out and they're coming inside and we didn't know, she will chase them around and play with them. She won't kill. Actually, she did kill one or two of them, but still. That's a good thing that cats are for. I can't wait to get Nimbus because, another cat to do that with. Anyways, elsewhere, conservationists work to increase the impala population so the endangered cheetahs have plenty of food to raise healthy cubs. These farmers and conservationists understand the population of carnivores and herbivores are related. If one population in a feeding relationship increases or decreases, the other population is affected. Okay, and now exploration 2. Some species within an ecosystem interact very closely. For example, clownfish live in anemones, birds live in bird nests in trees, and humans and dogs have loyal relationships. One species may depend completely on another for survival. Without the hard work, action, of the fig wasp. For example, fig trees could not reproduce. Fig trees produce flowers, but these flowers are all grouped together inside a structure that has a tough skin. This structure is also referred to as a fig's fruit, like fig Newtons. The only tiny fig wasps will bore into the fruit, pollinating the figs as they feed. Oh, there's a little marlin Nemo fish. So how does the interaction between... Yeah, we'll skip it. If you didn't know, the anema that the clownfish and the Nemo fish live in is living. As scientists study ecosystems, they observe patterns and strategies in the strategies organisms use to survive and reproduce within a community. Many of the patterns include symbiotic relationships. Symbiosis refers to the close long-term relationship between two species in an ecosystem. Symbiosis, the two different organisms living close in association with each other. Many symbiotic relationships help organisms get important non-living resources from the environment. For example, animals gain nitrogen from making proteins from their food, but plants also need a source of nitrogen. Take a guess what that nitrogen is. Bacteria living in the roots of many plants provide nitrogen. In turn, the plant's roots provide energy-rich sugars to the bacteria. There are three types of symbiotic relationships. They are categorized based on each organism's benefits is harmed or unaffected by the relationship. That's what we're going to cover in this one. I think that's it. Then wait up, let me just double check. Oh, perfect. We're almost done. So the two types of symbiotic relationships. So the thick fur and the tick lives in the dog's fur and feeds off the dog's blood. As it feeds, the tick exposes the dog to microorganisms through the transfer of blood. There's the remora fish follow or attract themselves through suction to whale sharks. Those little fish right there. Like a wishy-washy. Sorry, Pokemon. Remoras feed on leftovers from other shark meals. Then pollen from flowers stick to the bee as it drinks nectar. While visiting the flower, the bee may transfer pollen from another flower. As a result of population, plants can produce. So the interaction between dog and the tick, the dog's organism, how is the organism affected? Is the dog benefiting or harmed or not affected? I'm pretty sure the dog is harmed. The tick obviously benefits it. The remora, I'm pretty sure it benefits it as well. I don't think the whale shark is affected. The bee is benefited, and I'm pretty sure the flower benefits as well too, actually. Let's check. Perfect. Good thing I double checked because someone said not affected. So there's mutualism. Mutualism occurs when both organisms benefit from an interaction. So like that bee and flower. These relationships usually occur between species that do not compete with each other, but there are some exceptions. For example, the zebra and wildebeest each feed off wild grasses of the savanna, yet they migrate together in large numbers across the Serengeti plains in Kenya each year. By doing so, they deter predators such as lions and cheetahs. Some mutualism interactions are so close that they involve one organism hosting another within their body. So like termites. Wait, what? Sorry. The Trimpnophia are unicellular organisms that live within the intestines of termites. That's what I meant. Sorry. They gain energy and they stay foam while helping termites break down the hard to digest wood. So there's communalism. Commensalism, I'm going to say. One organism benefits from an interaction and the other is unaffected. For example, so that would be like the remora and the whale shark. For example, ant birds in a tropical forest follow behind army ants. The ants, they eat small insects driven from plant leaves by the stampeding ants. high above the ground. Certain bromelia plants wrap tough roots around upper branches of the rainforest to get sunlight. The ants and trees are unaffected by the interactions. Organisms that benefit the communalism are able to take better advantage of environmental resources. And this is the parasitism. Predators kill and eat their prey, but parasites may feed on the host organisms without killing them, so that's the dog and tick. While the parasites benefit from their interaction, the host is harmed. Fleas, ticks, and leeches are examples of parasites that feed on the blood of animal hosts. These parasites are attaches to each of the host. Some parasites enter the host's body to obtain what they need. Tapeworms live within the intestines of some animals. They eat from the host's undigested food as well as fewer nutrients that are left from their host. So have you ever had like a leech on you? Like I remember back in the day, like 20 years ago, when I was like 5, playing in a creek, and there was like a couple leeches. So like the leech was like sucking my blood and such. So yeah, and I think we're just moving to exploration 3 now. Let's double check. Actually, let's do this one. So here is a daughter plant. It has no chlorophyll. It's when it winds its stem around another plant, then the daughter sends root-like organs into the host plant and steal food. So do you think it is mutualism, predation, communalism, or parasite? A puzzle. I want to say it's parasite because it literally is injecting something into it and stealing its food. Let's check. Awesome. I was right. And then the last part for exploration 3 is the predicting effects of competitive interaction. So last lesson, we talked about competition between animals to get resources. Anyways, so all I'm going to do is cover this part. Competition for resources. Organisms with similar needs tend to compete for resources. A plant, for example, requires sunlight. The tallest tree in a rainforest creates a canopy that blocks the sun. Therefore, plants below must compete for limited light passing through the leaves of taller trees. Some plants have adaptations that help them gather light. They compete excessively and build a stable population size. Liana vines, for example, may grow as much as 915 meters to reach sunlight available at the rainforest canopy. The interaction that occurs between organisms when they both seek the same resource in the ecosystem is called competition. Each organism or population gets less of the resource than it would if there were no competitors. For example, in dry environments, many organisms compete for limited water source. So competition is just the relationship between 2 or more organisms competing for the same type of resource. And okay, I don't want to type. But anything else I need to cover? Let's see. And just like that, I think we're done. Okay, yeah, that is it. So for homework today, you're gonna be playing a game, and you're gonna be practicing basically some competition, kind of between other people, but also of animals. So when my first year teaching science at Ader, this is something that a kid showed me, and I was like, oh, this is actually kind of a great tool to use. It's a game called Mope.io. There's 2 parts that you're gonna do. You have a worksheet to go along with it, and then the game. So I'm gonna go over the worksheet first, okay? Actually, maybe not. So you're gonna be playing Mope.io with studying food chains, webs, and ecosystems, etc. You're gonna be recording data for what happens in the game. Make sure you put down the consumers, so the predators, the producers' prey, and the decomposers. Because really, yeah. So all the questions are going to the same. There's technically 5 rounds. You only have to do 3. 3 rounds. And these are the questions you're answering. What character do you start with? What did the character consume? So, like, what did it eat? What did the character try to escape from? What happened to your character? Did it change or die? And if it changed, what did it change into? If it died, why did it die? So this one is the one you're going to keep answering until you actually die. So I'm going to kind of show you what it is. I'm pretty sure some of you have played it before. Yeah. Ooh. I think I was going. Oh my god, it looks like I'm going slow. Anyways, try to be on one of the Chicago ones because that's not within the same time period, whatever, as us. I just picked the smaller one, so I'm just gonna go with teacher, whatever. It's gonna have you pick one of 4. I'm just gonna go with the chipmunk because that's cute. You move around with the mouse. So your goal is to avoid red players and eat things circled in green. So like there's grapes. That's what that is. I can't eat that yet. But the blue thing's water. There's some stuff in green. It looks like an acorn, but I can't eat that yet because I'm too big, too small. But this red thing, that's another living thing. Pretty sure it's meat, like a worm. We'll go with. Yeah. Blue's water, obviously. Keep eating, keep eating. Awesome. I'm not getting any bigger. Oh. Press S. Sometimes they'll give you little hints like that. Oh, I'm swimming. That's what that is. Okay. But yeah. So like your goal is to survive. I really want to know if some of y'all played this. Ooh, like there's other animals. I wonder if that will try to eat me. Oh, it's somebody else. Oh, that's ice. There we go. There's more food. There I go. I'm getting bigger finally. So you're not going to, so heads up, when you are playing, you're not going to be able to move into another ecosystem. So then you're going to be able to switch to another animal that you pick, whatever. I'm going to hit desert chipmunk because it switches you to a different ecosystem. Okay. Oh, wait, what? I could spit food? Ah, that's so cool. Zoom, zoom. Zoom. Ooh. And I was eaten by a plant. Oh, and sometimes you need to escape. The stone heals me at what? So obviously I need to stay away from these. I'm gonna switch to a penguin. Yeah, and there's different abilities that you get with it too. Left click to run. Oh, that's cool. Does it let me eat these things? I feel like I'm a Twitch streamer. Let me go zoom zoom. Zoom zoom zoom. Okay, I'm looking for something to eat me though. Oh, I can eat that though. It's in green. I'm gonna eat it. I'm gonna eat it. I gotta knock down this bar. Ow. Let me eat it. Yeah, you better try. I killed an animal. But yeah, that's kind of the goal of the game. You wanna. Let me see if I can try dying. Let me find something that will kill me. Hello, I need something to kill. Yeet Master, please come to me. Yeet Master. Does that do anything? Wait, what? Ah, that's so cool. Yeet Master. Okay, anyways, but you can die too, just a heads up. Apparently I'm not going to die. Crap. Wait, is that a... Okay, yeah, whatever. So anyways, Wait, please. Anyways, so I changed a couple times, and on here you're gonna tell me if you changed or died. Obviously, I wasn't lucky enough to die on it. But yeah, so you only have to do 3 rounds of it. Something different, something easy to practice food chains and such, and ecosystems, and competition because you saw all those other animals. So yeah. Once you're done with those 3 rounds, you're gonna tell me. You can obviously keep playing. There's enough for 5 rounds if you want to. If not, you can keep going. And tell me how many levels did you play. So like, how many times did you change, or how many times did you play, etc. It doesn't matter. If you passed several levels, what strategies did you use to get through all your levels? If you lost, what could you do differently? Okay. Those are the last 2 that you're answering. Other than that, have fun and play the game. Unless I get told after that you can't. We're not gonna unblock. It's not gonna get unblocked. If that does happen, I'm so sorry. There's gonna be another video attached. So yeah, have fun, be safe, survive.